Hello everyone. Today we are going to discuss problem number 3 under electrostatics in plus 2 physics. The problem is 5 identical charges capital Q are placed equidistant on a semicircle as shown in the figure. Another point charge small q is kept at the center of the circle of radius capital R. Calculate the electrostatic force experienced by the charge Q. So this is a semicircle and at the center is small q, charge small q, and these are the capital Q's: charge 1, charge 2, charge 3, charge 4, charge 5, and this is radius R. For that we are consider a circle of radius R. We have considered a circle of radius R, and these are the 5 identical charges, and at the center is charge small q, and the force is acting due to this charge 1 is acting along this downward direction, and this is F2 vector is the force experienced by the small q due to this capital Q, and F3 is charge experienced by small q due to this charge 3, and F4 vector is force experienced by small q due to this charge 4 which is acting along this direction, and F2 is acting along this direction, and F5 is charge due to this fifth charge acting on the small q, charge small q, which is acting along this positive y-axis. These two forces F1 and F2 are acting in opposite directions. Here the magnitudes of all the charges magnitudes of all the charges are same, in the sense the magnitudes of all the forces are same, only the direction of the action of the force directions only are different. Now according to the superposition principle, F total can be written as F1 plus F2 plus F3 plus F4 plus F5. Here F1 is equal to F2 equal to F3 equal to F4 equal to F5 equal to F. Here F1, F2, F3 are nothing but the magnitudes of force F1, F2, F3, etc. respectively. And generally a force F can be written in terms of its component as Fxi plus Fij plus Fzk, where I, j, k are the unit vectors. Fx is x component of vector F, Fy y component, and Fz is z component. Now based on this expression, we can write the expression for F1 vector as F1 y into j cap, because it takes place only along the y-axis, the two in negative y-axis, so that's why we put negative sign, and the unit vector along y-axis is j cap, and F1 y is nothing but F. The magnitude of the force here is F, so minus F into j cap is F1. Similarly F2, F2's z component is 0, and it is acting between x and y axis, so it has its component both along x axis and y axis. For calculating the x and y component of force F2, we are considering this right angled triangle. Here in this triangle, this angle is 48 because the entire angle is 90, so half of it is 45 degree. So here adjacent side of the right angle triangle is x component of Fx, and in this right angle triangle this angle is 45 because the alternate angles are equal. If this angle is 45, this also should be 45. That is a basic thing. So here in this right angle triangle, opposite side is this, that is nothing but y component of F2. So now, adjacent side is h into cos theta. That is the basic thing we knew already. Based on that, we can write the x component of F2. That is F2x as f2 into cos 45. In the same manner, opposite side is h sin theta. Opposite side is nothing but y component of f2, that is f2 into sin 45. So we can write the values of, expression for f2 as fx cos, f2 cos 45 into I cap minus f2 sin 45 into j cap, because this y component of force f2 is taking place along the negative y-axis. Y component is taking place along the negative y-axis. So that is minus f2 into sin 45j. That is f2 can be commonly taken as f. So f2 cos 45 I cap minus f sin 45 into j cap. And this is f sin 45 into j cap. Similarly, f3 is has only x component, y and z components are 0. So f3 is f3xi, that is f3 into I cap, f3 is f, so f into I. Similarly, f4 is found to be in the same based on this same concept. f4's x and y components can be calculated using these two right angled triangles. The adjacent side and opposite sides are calculated, and they are found to be f cos 45i plus f sin 45 into j, and f5 is having only y having only z component, that is f5 y into j cap. f5 y is nothing but f into j cap. f5 takes place along the positive x-axis, so here we have positive sign. Now substituting the values of f1 vector, f2 vector, etc. in f total vector, we get this is f1 minus, value of f1 is minus fj, and f2 is vector f2 is f cos 45 into I cap minus f sin 45 into I cap, and f3 is f into I cap, and f4 is f cos 45 I cap plus f sin 45 j cap, and this is f5, that is f into j. So here negative fj and plus positive fj get cancelled, and minus f sin 45 and plus f sin 45 j get cancelled. So on simplifying this, we get f I cap plus 2f cos 45 into I cap. f I cap is common taken outside, and 1 plus 2 into cos 45 is 1 by root 2. And here I cap is written at the last, and f is f into 1 plus 2 is root 2 into root 2 divided by root 2. Root 2 get cancelled into I cap. So f into 1 plus 2 root 2 into I cap. So f total is, here we are substituting the expression for f, and that formula is qn q2 divided by 4 pi epsilon naught into r square. Here q1 is capital Q, q2 is small q, and 4 pi epsilon naught, small r is capital R here in this case. So q divided by 4 pi epsilon naught r square into 1 plus root 2 into I cap, and unit for vector Newton can be written inside the bracket if you want. Thank you.